Honorable Mention 1. Kilobot. To some, 1,000 tiny robots running around in a swarm might be a futuristic fantasy, but to many, it sounds just as terrifying as a swarm of cockroaches. Around 2011, a group of roboticists from Harvard University developed a small unit of about 25 robots. By 2015, they had over 1,000. These kilobots are tiny robots created by Harvard researchers Radhika Nagpal and Michael Rubenstein. They stand less than 3.5 centimeters tall and are swarm robots. Swarm robots are a classification of robots designed as multiple individual robots that work together as part of a singular system. A popular example of this at work is in coordinated drone displays, such as the one presented at Lady Gaga's Super Bowl performance in 2017. Although these robots are called kilobots, they aren't armed with any dangerous weaponry. In fact, kilobots are completely harmless. Each one costs less than $14 to build. The robots move around by vibrations sent through their legs. They communicate with the rest of the swarm through infrared transmissions. While each robot does little more than wiggle around, sometimes messing up or breaking down, when you have over 1,000, the collective swarm will succeed. In dealing with swarm robotics, most developers stick with constructing the robots digitally using 3D modeling and simulation software. Before these Harvard researchers built their miniature army, most roboticists wouldn't have dared to spend resources on building non-digital creations. What do these robots do? As of now, their most developed skill is self-assembly. By communicating with each other, the robots are able to organize themselves into various shapes, such as a starfish. But many believe that these kinds of robots can be used to better understand natural behavior, such as in schools of fish or even humans. Honorable Mention 2. Blood cleaning robots. If someone announced 30 years ago that they were creating intelligent robots small enough to swim through your human blood veins, they would have been called crazy. But in this technological era, scientists have made unbelievable discoveries time and time again. Roboticists at the University of California, San Diego have created microscopic robots that have the ability to cleanse human blood of bacterial pollutants from the inside. These machines, referred to as cell-like nanorobots, are powered by ultrasound and are able to swim through blood to remove bacteria and their toxins. Each nanobot is about 25 times smaller than the width of a single strand of hair and swims at a rate of 35 micrometers per second. The nanorobots are built by combining gold nanowires with the membranes of human blood cells and platelets. The hybrid membrane coating gives the nanorobots the benefits of two different kinds of cells: red blood cells, which counteract the toxins generated by bacteria, and platelets, which limit pathogens. As an added benefit, the membrane coating also shields the nanorobots from biofouling, a bodily defense mechanism during which proteins cling onto foreign objects to prevent them from harming the body. While these nanorobots are still in development, researchers are hopeful that the technology could be monumental in the field of medicine. During clinical testing, blood samples polluted by a type of bacteria called MRSA were treated with nanorobots. Within 5 minutes, the samples contained 3 times less bacteria. According to researchers in charge of the cell-sized nanorobots, the end goal is not only to use them to treat MRSA bacterial infections, but also to cleanse biological fluids in general. The researchers also intend to perform tests on animals and craft the nanowires found within the membranes out of biodegradable materials rather than gold. Number 1. Cell-sized nanobots. The researchers from California, however, are not the only ones who have engineered nanorobots. A group of scientists at MIT has created robots just as small and much more complex. The nanorobots from MIT are the same size as a human egg cell. They are made up of two-dimensional electronic circuits attached to tiny particles called colloids. A colloid is a mixture, or the particles in a mixture, that cannot be dissolved, so they remain floating throughout a substance. By combining nanorobotic technology with colloids, the researchers aim to develop robots that can move through substances to perform diagnostics. While medical researchers hope to send these nanobots through the human bloodstream or digestive tract, some have pointed out other uses, such as in oil pipelines and plumbing. Smaller than a grain of sand, these nanobots are so tiny they can literally float in the air and could potentially be used to measure atmospheric properties. What really sets these nanobots apart, however, is that they are designed to be controllable. While other devices can match these nanobots in size, they rely on the flowing of liquids and air to move. The MIT researchers are specifically looking at ways to make their nanobots more mobile, such as by adding tail-like flagella. These nanobots are also self-powered. Using a tiny semiconductor, a small jolt of electricity powers the robot's miniature circuits. Regarding these nanobots, one thing's for sure: should they turn out successful, biotechnology will never be the same. That's all we have for you today.